Hello, everyone. Welcome to our ProMat DX digital experience session on how to analyze your data to prepare your warehouse for automation. We have two hosts today co-presenting. My name is Ryan Smith. I'm the VP of Automation for Westphalia Technologies. And with us today, we also have Alex Eisenhart, who is our solutions architect. And we often work together to help design a system for our customers that will fulfill their warehousing or order fulfillment needs in a distribution center. We thought we'd make today's session a little interactive between Alex and I, and is very similar to how we have our meetings internally when we want to design a warehouse. So we're going to talk a little bit about how to interpret the data and create a meaningful warehouse design that's based on the data that the customer gives us. It starts with the customer's data. It's very important to analyze it and interpret it properly. And it starts with every bit of detail that we can get. So it might start with an item master. It might start with order data and go from there. And as much as they can provide, we are going to want to analyze and crunch. Today, we're going to be using a tool called Microsoft Power BI to analyze the data. Alex has made several charts and tools and summaries that will interpret this data for us from a fictional company called Acme Anvil. The Coyotes have been very busy this year, and the business is better than ever. And they are shipping all kinds of things out to those Coyotes to hopefully get that Roadrunner this year. So with that, Alex, ready to get started?
Sounds good. Thanks, Ryan. I'm going to pull up the analysis here.
Fantastic.
All right. Can you see my screen?
Yes, sir, I can. And
excellent.
I can see it, although I will need my glasses to read it. All right, very good. We did have some ambient and cooler data, I see, although the cooler data is not very much.
Yeah, so the first thing I like to do is, this is a summary page that shows us 1 year worth of order lines. And like you said, we have two storage areas here. We have an ambient or a dry storage, and we have a cooler. And the cooler is shipping about 16% of the total volume, and the ambient ships about 85% of the volume. So at a glance, this tells me that their ambient dry products definitely are selling much higher rates than the cooler products. Annually, the whole facility is shipping about 24 million cases, and that's the equivalent of 330,000 pallets. Like you said, 84, 85, and 15 split. So I think this is an important fact to look at, because this is a way to make sure that the numbers and the analysis that I'm looking at, that the totals line up. If the customer told you they're shipping 50 million cases and I'm only seeing 24 million, then we're sizing a system way smaller than they actually need. So the first step is definitely to make sure that these high-level totals kind of make sense. So we're comparing apples to apples.
And this is very much in line with what the data they gave us is. So that's perfect.
So, fantastic. Another thing I want to point out is that we can very easily slice and dice this analysis based upon different business sectors or product lines, or if it's private label, we look at the customers that are receiving the product. In this case, they have two business sectors, and we can look at that. Not very interesting for this conversation. But to make this easy, I'm going to hide the cooler area, and we'll just focus on the ambient dry system going forward.
That makes sense.
Yeah.
So before you get too far, can I ask what the turnover is on this ASRS? So how much turnover are they having per year on the product? I'm just trying to figure out how big I want to make this ASRS. If I know the number of pallets and I know the turnover, that can help me get to that information.
Yeah, I can answer that. I need to switch to another page for that one.
Sure.
If we look at the inventory snapshots that we have.
Okay.
Yes. So their inventory snapshots, it looks like we only have 2, and it's looking like just about 22,000 pallets max for their ambient system.
Okay, that answers that question. And I'll let you go back to the summary page there. What were you going to say next?
Yeah, no worries. So for this system, they're shipping 20 million cases annually, the equivalent of 265,000 pallets. So that's pallets going out the door, about that much volume going out. The question, though, is how does this break down into different picking areas? How often then can they fulfill with a full pallet? How often do they need to pick cases by hand, or can we automate layer picking? This pie chart here is a good summary of that. So in their ambient system, 73% of the volume that they ship can go out in full pallet quantities. 22% can go out in full layer quantities, and 5% can go out in loose cases. So that means there's a lot of opportunity to automate full pallet order fulfillment here. And
Absolutely.
there's a significant value in automating the full layer volume as well. So when we were looking at the cooler system, it seemed like the cooler had less full layer volume, but definitely for the ambient, some big wins here.
Okay, well, that means that I have to do some homework, and I have a very good potential of coming up with an ROI for layer picking. So I'll start educating the customer on that subject. That's fantastic. How many pallets a day do we need to handle? I think I need to figure out how many machines I need for this job, how many storage machines I would have, and if we do the justification for this layer picking, I'll need to know how many robots we'll need for that.
Yeah, that's a great question. So like I said, 20 million cases annually, about 270,000 pallets annually. Day to day, though, I love this page. There's a lot of numbers. So yeah, if we look at this on a day-to-day basis, I have this chart here on the left, and I have several measures that go down the left side. The first column shows us the value for the average day. So for example, on the average day in the ambient system, they're shipping 34 trucks. The second column shows us the peak day. So on December 4th of 2019, they shipped 129,000 cases. That's the day where they shipped the most case volume. So that's the worst day in terms of cases out the door. But like you said, we need to size for the amount of automation that we have. So looking at the absolute most that we see on any given day is an important thing to do. So this third column shows us for each measure on any day, how bad does it get? So in terms of pallets out the door, we're looking at about 736 pallets on the average day. On their peak case day, they shipped 1,500 pallets. But due to tie-high differences and things along those lines, there is another day where they actually shipped 160 or 1,600 pallets. So that's the target that we really need to make sure that we can handle at the very least.
It sounds like on their average day, we can get them down to one shift, which they're going to be super excited about. Okay, that's great. Let's talk about the layers then. What's the velocity looking like for the layers?
Yeah, that's a great question. So this yellow area shows us information about the layers, and this is very important if we're looking at automating layer pick. We need to understand the daily capacity of what it needs to handle. So on the average day, we're looking at about 600 layers on average. The peak day, we're looking at about 1,700 layers. Now, if we can automate this, that would save the need to manually pick about 40,000 cases on that peak day. So that's a huge win if we can get that to work. In terms of SKUs, though, because the number of SKUs that we're picking from, the number of products involved in layer picking, that's a very significant number that drives the technology that can be selected. We're looking at about 176 SKUs on the average day, and about 317 SKUs on the worst day of layer pick.
Okay. That tells me which layer picker I need to select for this project. That's fantastic. Again, I think I can get them down to one shift here with the right number of robots. And again, they're going to be very excited about that because they've really struggled to staff that second shift, especially since COVID has hit. Okay, yeah. So I'll tell you what, if we go with a manual pick area, because it looked like that was really low volume, how many pick faces are we going to need over there, and what does our Pareto look like? I know that's two separate questions, but...
Yeah, that's a great question. So the volume is very low. On the average day, we're looking at 2,700 cases picked by hand. Worst case, we're looking at right around 7,500. That's the equivalent of around 90 pallets picked by hand. In terms of SKUs, that's 127 SKUs on the average and 237 for the peak. So that's the volume that we need to deal with and the products that we need to make sure that we can support. In terms of pick faces, we need to look beyond this, because if we sized for the peak day, and if we had static slotting, we put a pallet on the floor, people walk up and they grab it. If you just look at it on the daily level, you would say, well, we need 237 places to put a pallet. That's the most SKUs we're going to see. But if we just did that, then we would run into the issue of, well, yesterday I had product A, but today I don't, and I need 14 more today that I didn't have yesterday. So we're ignoring that swap out. You know, on the average day we have 127, but tomorrow we might have a whole different 127. So looking at this on a weekly and a monthly basis is very useful. I have a slide for that, if I can find it. I could talk for hours about this information here, but I think you have a meeting in a little bit.
I think you're the only man in the universe that would say that, Alex.
Oh, man, it's fantastic.
That is why we love you.
So this fifth column here on the right, excuse me, this shows us the number of SKUs in the top by day, excuse me, by week, and by month. I get very emotional over this slide. It just ties it all together for me.
Is it the colors?
Definitely. So like I said, on the average day, we have 127. It's dim, but 127 SKUs on the average day, and we have a peak of around the high 200s-ish. But if we look at it week to week, we're seeing 323 SKUs for the average week and 500 SKUs for the average month. So with static positions on the floor, and we don't want to swap them out every other day, shooting for somewhere around 500 would be reasonable. That might take up a lot of real estate if we're storing full pallets on the floor. So this would probably be a good candidate for some sort of dynamic slotting solution, so that we don't need to actually have 500 dedicated spots on the floor for each SKU.
That makes sense. If we do go with a dynamic solution, how many hits are we looking at?
Yeah, that's a good question. So we've talked about the velocity, how many cases we need to hit per day, how many cases we need to pick manually per day. We looked at now the product lines, how many products are we going to touch on each day, but your question now is the hits. And the hits are really interesting. A hit is a way to answer the question of how often is a picker going to have to walk up to a location and pull product off of the pallet that's stored there. So the hits in the loose case area are only 321 per day. So that tells me that to pick the 2,700 cases out of loose case from the 127 SKUs on the average day, we're only going to have to walk up to a location 321 times. So that means that when we go to a location, we're going to have to pull off more than one case at a time. Less than a layer, because if it was a layer, we'd throw it into the layer picker.
Sure.
But when we go to a location, we're picking a good amount of volume, so we should get a good rate for picking.
Okay, and you know what? There may be an opportunity to do some case flow lanes here. Show me that Pareto just so we can see what the A, B, and C's look like, and maybe we can put some of those very low moving C movers into or what we like to call the cats and dogs, into some case flow lanes to save us some space here.
Yeah, that's a great question. I'm going to zoom in on this chart. This is their shipment Pareto. I love Paretos, but I really don't like making them because it's a lot of calculations just to store this so it can run quickly. So what this shows us is the curve of which products move fast and which products compose the fastest moving parts of the business. So for example, their number one mover represents 3% of all of their sales. If we look at their top 80%, about 235 or so SKUs would represent the 80% of their business, the majority of their business. As you said, the cats and the dogs, the top 90% is probably close to around 700 SKUs. I have a little chart back here.
697. You were off by 3.
Yeah, look. Oh, man. I used to be better. So we have about 200 A's, about 260 B's, and about 700 C's in terms of total volume out the door. But like you said, if we're looking at some picking some case flow lanes, we need to look at the size of those cases as well. So let's jump into that actually. The case dimensions, they look pretty reasonable. The majority of their volume is 13 inches wide by 13 inches long, and the heights are all less than 13 inches as well. We're seeing a lot of 9s and a lot of 11 inches, so fairly reasonable, consistent size cases.
Well, we will need to check with the engineers. I'll have to ask if we can pick up 2 cases at a time at that 11-inch height. That might make our layer picking more efficient if our robot can do that. So I'll check with the engineers and make sure that that's possible. If not, we may need to do a couple extra moves if we're moving 1 layer at a time as opposed to 2. So let's keep that in mind. We are running low on time here, Alex. Let's quickly look at the pallet size, the overall unit load dimensions.
Yeah. And why is that important at this
point?
Well,
you know, we do need to design the height of the levels in the system, and I just want to make sure that we're not going to need some crazy 110-inch unit load heights here for storing. And it looks like we are in pretty good shape here. What are we seeing?
Yeah, so if we look at the height first, here's a quick distribution of their pallet heights, not including the pallet underneath, just the product load. You can see the majority are less than 48 inches. This table up here, we can see that there are 2 SKUs that are 126 inches, but they only 39 cases of these SKUs, so that's probably packaging material or maybe displays. I'll make a note to follow up with them on those. Yeah, we'll probably trash that.
Yeah.
But everything else is 49 inches or less. So adding the pallet height, 54 inches seems reasonable. In terms of weight, looks like the heaviest pallet is about 2,200 pounds. So that's not too bad either.
That's perfect. That's perfect. Yeah, we can use our standard machines for this. That's great. Okay, fantastic. I think that answers all of the questions that I had. Now we can turn this over to our solutions designers and our applications engineers to come up with a great solution for the customer, and I can start talking to them about layer picking and educating them on that, because I think there will be a great ROI for them with the numbers that we're looking at today. So with this information, and just to circle back to the purpose of our session today, this is pretty typical for how an analysis goes on every single project that we look at. And there are a lot of pieces of information that you may or may not have, but you really want to try to find out for whatever system you're designing. Maybe you're not designing an ASRS, maybe you're designing something else. That's okay. The same principles apply, and we encourage you to employ the techniques that are similar to what we've shown here. Use a tool like Power BI. It doesn't have to be that tool, but use something like it so that you can properly analyze that data and look at it from every angle possible so that you can best determine the solution for your customer. And that's what's important to us. We don't want to design a system that we deliver to the customer in 2 years and then find out, uh-oh, we didn't account for this. So it's extremely important that you are analyzing every single data element from top to bottom. So with that, I hope you found this useful. Are there any questions?